Okay, so I'm going to illustrate exhaustive search now. Suppose in this example, we have a target called sales, okay, and then we have 5 available predictors, okay, for the sales force. So these are the sales representatives, okay, 5 predictors, and we want to predict how much will be the sales for each of those representatives. So what we want to do is to look at all possible, and we have data. Okay, so here is your sales, then we have 5 predictors, and we have data right here, and suppose we want to use all possible combinations of subsets and select the one that is best. Okay, so what are the possibilities? So we can have one predictor taken at a time. So you have 5 of those. We have y with except 1, y with except 2, y with except 3, except 4, except 5. There are 5 of those. Or we can take 2 x's at the same time. So y with except 1 and except 2, except 1 and 3, 1 and 4, 1 and 5, and then 2 and 3, 2, 4, 2, 5, 3, 4, 3, 5, and then 4, 5. So those are the possibilities with 2 predictors taken at a time. Okay, that will be 5 combination 2, which will be 10 possibilities, right? And then 3 taken at a time, again it's 5 combination 3, 10 possibilities, except 1, 2, and 3, except 1, 2, and 4, except 1, 2, and 5, and then except 1, 3, 4, 3, 5, then except 1, 4, 5, and then you start with except 2, 3, 4, 2, 3, 5, 2, 4, 5, okay, and then 3, 4, 5. So 10 possibilities. Okay. And then 4 x's taken at the same time. So 1 through 4, and then 1, 2, 3, 5, okay, and then 1, 2, 4, 5, and so on. There are 4 of those, and then all 5 variables taken together. So here are the number of predictors, okay, and the R squared for each of them. So for the first 5, R squared is very simple. There is a RSQ function available, okay, and you can use that function to find the R squared value for the first 5. And then when you have more than 1 x's or 1 predictor, the RSQ won't work. So I wrote a very small macro for that, which is this. Okay, so that this will select the R squared value, okay, so which is what you see here. So we have all, so this one is all of them. Okay. Now here I have x1 and 2, and then 1 and 4, 1 and 5, 2 and 3, and so on. So I have all combinations of 2x variables, and I have the R squareds computed for each of them. Okay. And then 3 variables taken at a time, and the R squared computed, 4 variables and their R squared, and of course all 5 variables is right there. So it's all already assembled right here. Okay. So the best predictor, okay, so here it will be like if you take the maximum R squared value for the 1 predictor case, so that will be that. Okay. And then the 2 predictor cases, there? So that's your 2 predictor cases. And 3 predictor cases are these, and 4 predictor cases of those, and then of course you have the full model. And now obviously when you use R squared value, he's going to always select the one with more variables. Okay. But now let's do the same thing with adjusted R squared. We have n is 30, right? So let's do n minus 1 is that. So now adjusted R squared, so here is the formula. So we have 1 minus, okay. So n minus 1 is that divided by, okay, n minus, okay, so here I need to, I'll do that, n minus p minus 1, okay, times 1 minus R squared. So that's our, I had a bracket wrong, so I need this to be absolute reference, that to be absolute referenced. So now I have the adjusted R squared copy this one over, and we get the the best adjusted R squared for each of those number of predictors. As you see here, the best predictor is that. So we can do a conditional formatting. All right, so you see when you use adjusted R squared, then the number of predictors, best number of predictors is 2 and not 5.